Let's make a multiplication table. A multiplication table is like a math crossword puzzle. So we'll start with a 10 by 10 blank table. Yours should look just like this. There will be one in your notes. To start, fill in 1 through 10 down the side of the table. Once you've counted 1 through 10 down the side of the table, then fill out the top of the table through 10. It's important not to use the number 1 twice. The number 1 will only appear once in the upper left-hand corner. Now, we'll go to the next row down and count by multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. You certainly need to be able to count by multiples of 2. And making a multiplication table is a great way to practice. Once you've mastered that, the next row down, fill in the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Definitely need to be able to count by 3s, multiples of 3s, to complete the table. Anything that is a multiple of 3 is divisible by 3 as well. Next, we'll count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Anything that is a multiple of 4 is also divisible by 4. Next, we count by the multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Again, anything that's a multiple of 5 is divisible by 5. The next row down, we'll count by 6s. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Anything that is a multiple of 6 is also divisible by 6. Next, we'll count by the multiples of 7. 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. Next, we'll count by the multiples of 8. 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Next, we count by multiples of 9. 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. Finally, we'll count by the multiples of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Well, now we have a multiplication table. Even though we created the table working horizontally, notice the multiples are the same working vertically. Notice that creating the multiplication table will help you memorize your multiplication. Notice the diagonal of square numbers. Square numbers are the result of any number times itself. Any number times itself is that number squared. So notice that 2 squared is 4. 2 times 2 is 4. 3 squared is 9. 3 times 3 is 9. 4 squared is 16, because 4 times 4 is 16. 5 squared is 25, because 5 times 5 is 25. 6 squared is 36, because 6 times 6 is 36. 7 squared is 49, because 7 times 7 is 49. 8 squared is 64, because 8 times 8 is 64. 9 squared is 81, because 9 times 9 is 81. And 10 squared is 100, because 10 times 10 is 100. For each and every multiple of 2, the ones digit will either be 2, 4, 6, 8, or 0. Multiples of 2 are called even numbers because they can be divided in half, meaning divided by 2, and the result will be a whole number. We know that 37,574 is an even number and can be divided by 2, or it can be divided in half because the ones digit is either a 2, 4, 6, 8, or 0. Odd numbers have either 1, 3, 5, 7, or 9 in the ones digit. Odd numbers cannot be divided in half. They cannot be divided by 2 and still result in a whole number. For each and every multiple of 3, the individual digits of the number will add up to a multiple of 3. We know that 18 is a multiple of 3 because 1 plus 8 is equal to 9, and we know that 9 is a multiple of 3. We know a number like 11,274 is a multiple of 3 because 1 plus 1 plus 2 plus 7 plus 4 equals 15. We know that 15 is a multiple of 3. For each and every multiple of 6, the number must be even and the individual digits will add up to a multiple of 3. So when a number is even, we know it's a multiple of 2. And when the digits add up to 3, we know it's a multiple of 3. And 2 times 3 equals 6. We know that a number like 557,424 is a multiple of 6 because it's an even number. We know it's an even number because it ends in 2, 4, 6, 8, or 0. And the individual digits will add up to a multiple of 3. 5 plus 5 plus 7 plus 4 plus 2 plus 4 equals 27. And 27 is a multiple of 3. For each and every multiple of 9, the individual digits will add up to a multiple of 9. So a number like 423,810 is a multiple of 9 because 4 plus 2 plus 3 plus 8 plus 1 plus 0 equals 18. And we know that 18 is a multiple of 9. If the individual digits of a number do not add up to a multiple of 3, then we know that that number cannot be a multiple of 3, 6, or 9. That means if the individual digits of a number do not add up to a multiple of 3, that it cannot be divided by 3, 6, or 9. For each and every multiple of 5, the digits in the ones place will always be 5 or 0. We know that a number like 312,675 is a multiple of 5 because the ones digit is a 5 or a 0. For each and every multiple of 10, the digit in the ones place is always 0. We know that 312,670 is a multiple of 10 because the ones place digit is a 0. So take a look at the multiples of 2 and notice they are even numbers because they end in 2, 4, 6, 8, or 0. Take a look at the multiples of 3 and notice the individual digits add up to a multiple of 3. Take a look at the multiples of 5 and notice that every multiple of 5 has either 5 or 0 in the ones place. Take a look at the multiples of 6 and notice that those numbers are always even and the individual digits add up to a multiple of 3. For each and every multiple of 9, the individual digits will add up to a multiple of 9. Look at the multiples of 10 and notice that they always have a 0 in the ones place. The multiplication table is also an excellent way to see equivalent fractions. Notice the equivalent fractions of 1/2. 1/2, 2/4, 3/6, 4/8, 5/10, 6/12, 7/14, 8/16, 9/18, and 10/20 are all fractions equivalent to 1/2. Notice the equivalent fractions of 2/3. 2/3 is equal to 4/6, 6/9, 8/12, 10/15, 12/18, 14/21, 16/24, 18/27, and 20/30 are all equal to 2/3. And this works for any fraction you can create using the counting row on the left or the ones row on the left. Notice the equivalent fractions of 3/8. 3/8 is equal to 6/16, 9/24, 12/32, 15/40, 18/48, 21/56, 24/64, 27/72, and 30/80. All of these fractions are equal to 3/8. It is essential that you are able to easily construct the 10 by 10 multiplication table and that you memorize the multiplication on the 10 by 10 table. Once you have mastered that, move on to the 15 by 15 table. And after that, even try the 20 by 20 table.